Thank you very much. Yes, today I would like to present to you our two models, ATOM and DREEM, which are part of the TEEM suite. Yes. When we were developing those models, we had in mind that we would like those to be able to perform participatory simulations and provide quick answers to what-if scenarios. And a bit in a different way that the most of the models in IAM Compact, we would like, we came up with two models that could be easily soft linked to such models to support providing answers to more complex research questions. The first one is ATOM, which is an agent-based technology adoption model, which correlates technology adoption with its value to consumers in order to perform the expected effectiveness of technology adoption under different policy schemes. And the main novelty of the model is that it allows to quantify uncertainties related to consumers' decision-making process. So in a sense, this could be perceived as behavioral uncertainty. Both models I will be presenting have been developed in a modular way. Same with ATOM, which consists of three modules, the first one being the calibration one. Then we have a sensitivity analysis and then a scenario analysis module. Starting with the first module, the calibration one, and for the indicative case of adoption of solar PV, we start with historical data and observations, and we come up with first set of technology-specific agent-related parameters, which based on Gaussian process simulation and other methods, we try to fit to our historical data. And for our agent-related parameter set, we try to come up with different socioeconomic and demographic profiles like income, education level, consumption profiles, or other parameters that, based on scientific literature, are assumed to affect the decision-making process of consumers. And then having the first set of agent-related parameters, and after fitting this set to the historical observations, we come up with a hybrid variance-based sensitivity analysis process to find the different parameters that introduce uncertainty to the results. And then we refine this set of agent-related parameters, and we come up with the final value ranges, which eventually we use along with other market parameters, market relevant parameters or policy schemes to the forward-looking simulations where we can see different adoption scenarios. For example, here in the indicative case of solar PV, we can see different future evolutions of how capacity addition of small-scale PV could evolve, for example, in Greece or other national scales. And of course, you see that we can play around with different behaviors, like, for example, willing to invest consumers or risk-averse consumers, and we eventually also quantify the uncertainty in investing. So some indicative applications now, we have been using the model under the Include project to explore the diffusion scenarios of energy communities or other grassroots innovations as eco-villages. So essentially what we did is to expand the model not only to go for adoption of technologies, but also for diffusion of social innovations. And in Sentinel, we have used the model, we have soft linked the model with Quotidian, which would be more of a toolbox about coming up with different sociopolitical storylines, so that we have different potential evolutions of the agent-related parameters and other parameters, and we use the model to assess net metering increase, feed-in tariff increase, or potential battery-based self-consumption schemes. And here I have included some relevant recent information about the model and scientific articles and reports. So that would be all about ATOM. And let me now also very shortly present The second model that would be DREEM, which is a dynamic high-resolution demand-side management model. It's an energy demand simulation model which can also assess benefits and limitations of demand flexibility, primarily for consumers and then for other power actors potentially involved. So it's a building sector model which is currently used under several Horizon 20 and Horizon Europe projects. So the key model specifications is that it can provide outputs at a high resolution. We can go for occupant behavior, all the potential determination of end-use qualities. It has, again, a modular structure, can be easily linked to economic development and technological breakthroughs, and bottom-up also structure. And we hopefully could use it to link it to several IAM compact models. So here you can see the overall model architecture and the modular idea behind it. So the idea and the novelty is that we use this component modular-based modeling approach. So to have independence of decisions between the different modules and components and hierarchical dependence of modules when we design the different applications, which allows and gives a lot of flexibility when it comes to different types of applications on the European transition to climate neutrality. And I have included here an indicative parameterization of the model. So you see that we start with the climate weather data for each one of the regions under study. We take such data from different sources. And then we go to the building envelope, let's say, component, which allow us to come up with either custom building envelopes or existing typologies from several databases. And then we go for occupancy and activity profiles based to Joaquin earlier presentation based on existing household budget surveys. So we also parameterize this module, and finally we need to parameterize along to occupancy and activity profiles the different end uses, which again we do based on budget survey on energy consumption, and this is an indicative example of such data for the case of Greece. So all these different modules are typically parameterized in the model for the baseline scenarios. And then we can see different other interventions in terms of the types of scenarios that we would like to simulate. And I have included here some indicative applications that we have used the model so far. For example, we have used the model in several EU countries to assess energy saving potential, the cost effectiveness of different energy efficiency measures in different residential house typologies. We use the model to calculate energy demand in the baseline scenarios and then calculate energy savings for the energy efficiency scenarios, and using the levelized cost of saved energy, a well-established techno-economic indicator. We use this to finally eventually assess the cost effectiveness, energy saving potential of the different energy efficiency measures. And here some indicative visualization that we do with the results. This is for the city of Madrid in Spain, for a building constructed between 1960 to 1979. And we do the prioritization and ranking of the different energy efficiency measures. So that would be one application of type of application of the model. The other one would be we used it along with representatives from the Greek Ministry of Energy and Environment to simulate the energy transition in the whole Greek residential sector by 2050, under different scenarios, to also consider all the developments and discussions around natural gas. And what we saw is that if we would like to completely decarbonize by 2050 the Greek residential sector, then we need to increase the annual renovation rate to 2.5% instead of 1.5, which is the current rate based on the latest version of the National and Climate Energy Plan. And we can also, the models allow us to go even lower in terms of scale and resolution. For example, we did similar, again, along with the ministry, we did similar analysis for regional scales, like the region of Peloponnese, where there is this discussion of new natural gas infrastructure construction. We needed to see if that would be I mean, the best solution, which of course isn't. And then also we dived more deeper to municipality level in megalopolis to see the just transition pathways. Megalopolis is a coal and carbon intensive region in Greece, and there is also this discussion about phase out of night now, and we explore different pathways, also having the just transition concept in mind. Again, here you can see some latest scientific articles regarding the tree model. And yeah, that's information about us. Thank you very much.